Our Mousetrap car directly relates to Newton's laws in everyday life. For example, in Newton's third law, when walking, you are actually pushing on the earth, and the earth pushes back, causing you to move. The same applies to cars, bicycles, and boats, including our Mousetrap car. Or simply rolling a ball shows us how Newton's first law applies. The second law takes play when we calculated the force with mass and acceleration.
Our car demonstrates Newton's laws because it is a vehicle that is powered by a wound-up mousetrap spring. Using the lever arm with attached string, we put the mousetrap into motion by simply adding wheels and adjusting the placement.
We use these materials listed for construction: 2 pre-drilled wood sides, 2 brass axles, 1 brass lever arm, 4 rubber DVD-CD spacers, 4 metal washers, 1 Victor mousetrap, 1 Ziploc axle hook, and a 36-inch Kevlar string.
Here you can see our finished model of the car and how it works. Maddie is winding up the string attached to the lever arm. When released, our car is off.
To follow our building, testing, and any calculations, visit our website, hopeandmaddie.mousetrapcars.weebly.com.
Newton's first law. Objects with a greater mass have more inertia and take more force to change their motion. Here you can see a tennis ball being rolled onto a flat surface and continuing in a straight path until acted on by the lockers. The law states, an object at rest stays at rest, and an object in motion stays in motion unless acted on by an outside force. Inertia is when this occurs. Our car acted the same way when it hit the lockers. The mousetrap car stops because friction in the locker are outside forces affecting the car's speed, or acceleration. Acceleration is the rate of change of velocity per unit of time, which leads us into Newton's second law. Acceleration is inversely proportional to mass. Newton's second law is F equals ma, or in other words, how much an object accelerates depends on the mass of the object and how much force is applied to it. F is force, m is mass, and a acceleration. If Maddie was our car and her mass was 0.007851 times the force of 1.67, she would be moving with an acceleration of 212.28 meters per second. Here are the actual theoretical and experimental accelerations of our mousetrap car. The car is demonstrating the experimental acceleration of 0.86343482 meters per second. One more example to show the relation between mass and acceleration is an elephant versus you. The elephant has a mass and a larger acceleration. You have a smaller mass and a smaller acceleration.
Newton's third law. Your action caused a reaction. Pushing on the wall causes you to pull backward. The law states an object exerts a force on a second object. The second one exerts a force on the first that is equal and opposite in direction. Or more easy to understand, for every action there is an equal and opposite reaction. Another example is jumping off the ground, because when you jump, your legs apply a force to the ground, and the ground applies an equal and opposite reaction force that propels you into the air. Here you can see a diagram of our mousetrap car from the instructions. The car is pushing down on the floor, and the floor pushes back with equal and opposite force.
As you can see, Newton's 3 laws of motion relate to everyday life, including our science project. proven from the demonstrations in this video. Here are a few more pictures from our project explaining everything we've done